Hello. Yes, we welcome you back again. We are still um, with grade 11, the chemistry, and we are having this question. The question says that hydrogen gas and oxygen gas reacts to form water according to the equation below. This is the equation where hydrogen combines with water, giving us combines with oxygen to give you water, and then plus this energy. Then the question, the statement reads that the activation energy for this reaction is given. We have it there. Then that's the end of the statement. Then the question comes, define the term activation energy. So what is it? What is activation energy? Activation energy is the minimum energy required for the reaction to take place. So there comes another question. It says, it reads, define the term enthalpy change. So what is enthalpy change? Enthalpy change is the amount of energy given out or absorbed during a chemical reaction. So that's that. Yes, then comes this question. Question 2.2.3. It says, sketch a potential energy versus reaction progress graph for the above reaction. They mean this reaction, and clearly indicate this. Clearly indicate enthalpy change. Indicate activation energy for the forward reaction, reactant, product, and activated complex. Now, before you start with the sketch, there's something you have to know. You have to know the type of reaction, whether it's exothermic or endothermic. Now, when you see this energy on this side, what side? The product side. It means that energy is given out. And the reaction which leads to evolution of energy or giving out of energy is exothermic. Now, if energy was on the reactant side, it means that energy is absorbed. And a reaction which proceeds with absorption of energy is endothermic. So what type of reaction is this one? The reaction is exothermic. So we are going to sketch the graph for an exothermic reaction. So this is the sketch. And on this sketch, you have to remember that here we have the potential energy in kilojoules. And here we have progress of reaction. We have enthalpy change here, delta H. The reactant R is there. The products are here. And the activated complex is there. So that is what they wanted you to put. That's what we have here is the sketch for an exothermic reaction. Okay. Then after that we come with this question, but we had forgotten to indicate activated complex, which was also needed here. So that's the sketch. Then after that, we come to this question. It says, write down the value for the heat of reaction. So when you go to the equation, we said that what you see here is the heat of reaction, and the reaction is exothermic. So the value is going to be negative 241.8 kilojoules. Okay, then comes the next question. Yes, then we come to the closing question of this video. It says that write down the value for the activation energy for the reaction. So this is the reaction they are giving us. Now, when you look at this reaction and go and compare it to the reaction given above, we notice something. What do we notice? We notice that this one is the reverse of the other one. For this one, it was hydrogen reacting with oxygen to give you water. While for this one, it's the water which is decomposing to give you hydrogen and oxygen. So it's the reverse. And if it's the reverse, how do we get the activation energy? So this is what you have to know. It's very important to know that when you are taking the activation energy for the reverse, we take this. We start from the product to activated complex. So this is what EA reverse. So if that's the EA reverse, how do we get it? This is what we know. From the statement, they gave us the activation energy for the forward. So from here up to here, we know it is 1370. It's 1370. That's what we know. Okay. And we know something else. What do we know? We know the enthalpy change, which is represented by this space here. So this one is 241.8. The negative comes because it falls below the level of the reactant. Otherwise, it's here we take it as it is as positive. So when you look at this, what do you see? That activation energy of the reverse reaction is the sum of these two. So it's going to be 1370 plus 241.8, giving you, okay, what do we get here? So that is what we get. It is 1161. Oh, actually, it's 11,611.8 kilojoules. Okay. Thanks very much for being with us. We thank you for subscribing. If you have not yet subscribed, please do so. We'll see you next time. Bye-bye.